Today we are going to learn how to deal with for and while loops in Python, and there'll be a couple of practical examples as well. And some of these examples will draw on everything you have learned in Python so far. So strings, sets, lists, and everything. At the end of this session, the video recording of this session will be uploaded to my YouTube channel, and this notebook will be deposited in my GitHub repository. Okay, so we will look at, the overview of for loops in general, and then we'll look at looping over a range. We will look at nested loops. Well, this is mostly nested for loops. Then we'll look at break statements in for loops, and continue statements in for loops, and pass statements in for loops. Then we'll look at while loops, which are just very similar to for loops, and infinite while loops, and a couple of exercises. I think 4 exercises for you to try at home. I really advise you to try these exercises, because I have carefully planned them, curated them, and they would require you to apply, all the skills you may have acquired from this class. Okay, so now let's kick this off with what is a for loop? Okay, and for loops are just used for iterating over an iterable. I know this is complex. Okay, this is funny. Okay, an iterable is just an object whose members can be accessed individually. Okay, so if you take a set, for example, a set of numbers, you can access each element of that set. Or you take a list or a string, as we saw a couple of weeks back. Okay, and you use for loops mostly to execute a block of code repetitively. Okay, so let's say you have a task that you want to do over and over again. Say you want to print from a file, okay, and this file has several lines of code or text or something, okay, and you want to print each line to the console or to your screen. So you basically use a for loop in this case, because it's basically the same task but done several times. Okay, and one good thing to note about for loops in Python is that you don't need an indexing variable. Okay, and I'll tell you what an indexing variable is later. Okay, now but before that, let's look at a simple example of a for loop. Okay, now let's say we want to print the elements of a string, any string. Okay, and in this case, let's say the string is George. Okay, we want to print each element, each letter of George to the console. Okay, and want to print these one after the other. Okay, and so we just use a for loop. Okay, because as we learned earlier, a for loop allows you to iterate over an iterable. Okay, in this case, the string. Okay, so how do you start a classic for loop? Okay, a classic for loop always starts with this for. Okay, so that tells Python that you're starting a for loop, and take note, this should not be capital. Okay, if you make it capital, it's no longer a for loop. Okay, so small f. Okay, x here is your indexing variable in this case, okay, and it can be anything, okay. Well, I don't say anything because there are certain reserved keywords that you cannot use it in Python, okay, but as long as it's not a reserved keyword, you can use it. You can say x is Sierra, for example, okay. So you say for x in, see, and you put the string, well, the iterable here, okay. So if the iterable here is y, just say for x and y, then you put this, okay, don't forget the colon, then that's a valid statement to start a for loop, okay. And what Python does with this statement is that it's going into that iterable, in this case George, and access each element of, or each character in this case, of that string one after the other. So it starts, okay. So that's why you're saying for x in. So you're basically saying for every element in this, do this, okay, but it does it one after the other. So here again, just as we saw in while loops, just indent one step, okay. So when you indent one step, you're telling Python to execute everything at that level, okay. So Python will execute everything at that level for each value of x, okay. So in this case, okay, yeah, so in this case we want to print x, okay. So you see, so it's basically printing GEORGE, you're done, okay. So it's as simple as that, okay. Now let's add some complexity to this, okay. So now let's say we want to print each element of that string, it can be any string basically, on the same line, okay. So here we saw that they were printed on separate lines, but here we want to print them on the same line but separate each character by a comma, okay. And again, it's the same, okay, for x. So we can even say for let's say for Abu, you see, so which means our variable here is Abu in this case, see? So for Abu in this, so in this case, you see, so we're saying now print Abu, which is just a variable. And okay, this is new basically because we want to separate them by commas, okay. Firstly, if you want to print them on the same line, just on the same line, this is what you put. You say end is equal to just dash, okay, I mean like an empty space, okay, white space. Then if you run this, you see that George, because you're not leaving any space between them, okay. So if you were to increase the space, the white space there, so you see that's what happens. So what you're telling Python is that say print this element, okay, and leave some space between them, then print the next element on the same line. So this is the syntax for that. So now we want to put comma instead of just an empty white space, okay. So you run this and you have it, okay. You could change this to even colon, okay. You run it and it's the same thing, okay. That's perfect, okay. So far so good. This is going very well, okay. Now for works not only with strings, okay, it can work with lists as well. Like this is a list. So let's say this in Python, this is what we call a list, okay. So this is a list of cities in Sierra Leone, okay, Kenemabu, Kono, Makeni, and Kabbalah, okay. We want to print each of them cities, okay. So now what we do, the same thing, just assign for, you can take anything for x in data, print this, and it's printing. It prints for you, Kenema, okay. And basically what this is doing, it's just doing everything in in the set, okay? But you can definitely choose, as you will see later, you can choose to print only a few, or two, or three, or or specific elements, okay? And you'd learn how to do that later, okay? So now let's add some complexity to this, okay? So now let's say for this example here, okay, here we printed them on the same line, okay? But now let's say for this example, we don't just want to print them, we want to print their positions as well, okay? So Kenema, for example, we know Kenema is in position 0, so we just print like this: 0 is to Kenema, 1 is to Bo, okay? How do you do that, okay? Now again, it's almost very similar, but there's a difference here, okay? Now you can see that basically we have two variables that we want to print. We want to print the content itself, and we want to print the position of those elements, basically, okay? And so what do we do? Okay, so we start here again. So now again, you can use any two variables, but here I have decided to use I and X because they are easy, okay? So so you put I comma X. So your I here is the position, okay, and the X here is the variable, is the element basically at position I, okay? And now instead of just saying IX in data, you use this inbuilt Python function called enumerate, okay? So you just say enumerate and put the input here, okay? This is your input list. So say for I comma X in enumerate, basically. So what this does for you is that it separates, it like obtains the position and the variable separately. So now you have the position, you have the variable, okay? So you can do anything with that, okay? So we want to print in this format. You should know this already. So let's say string to print. String to print is just a variable, okay? It's just, we're just naming our, the string we want to print as string to print, okay? And this is how you format it, okay? So you know that if you put, okay, to start a string, you need these how do I call them, those inverted commas, okay? And because we want to put these as variables, you just put this empty curly bracket, okay? And this symbol is just this symbol, and this empty curly bracket as well. And we put format IX, so which means this position will be I and this position will be X, okay? So this is it, and you just print, and it prints it for you, okay? So if we run this, we get what we want: 0 is a Kenema, and so on and so forth, okay? And I think that is very simple, okay? So now let's go to looping over a range, okay? So let's say we want to loop over a range, okay? So let's say we have a list, a list or a set, okay? And we want to loop over this set for a specified number of times, okay? Or we have a block of code we want to basically run, but we want to run this, say, for 5 times and nothing more, or for 2 times, or for 3 times and nothing more. So in this case, we can use a range function, okay? So now let me tell you about the range function in Python, okay? There are a couple of usage options for the range function in Python, basically, okay? So the first usage option is when you say range n, okay? Range n means you are defining a range starting at 0 and ending at 0, at n minus 1, okay? So it increases by 1 step, okay? So what that means is that, so let's say we say range 6, okay? Range 6 means we are basically defining a range from 0 to 5. So the last one is not included at all, okay? That's something to note. The upper limit of the range is discarded. So if you say range 0 to, range 6 is 0 to 6, okay, good. But if you were to display the numbers in that range, okay, so if you want to display the numbers in that range, just convert that range to list. Just say list, then you put a range here. So this converts the range for you to list. So if you see, if you display this now, you see that you have from 0, 1, 2, 3, 4, 5, but not 6, okay, and it's normally chronological, okay, it increases by 1 step every time, okay. So now let's see how we use this in for loops, okay. So now let's say we want to print, basically we want to print the first 4 elements, only the first 4 elements of this list, okay. If we wanted to print every element of that list, it would be easy. We would just use the previous approach or the preceding approach, okay. But here we don't. We have a specific number of elements we want to display, okay. But now let's try to analyze this, you know, logically, okay. Now if we say print the first 4 elements, so bear in mind that lists in Python start from 0. This is something you should note, okay. So if we want the first 4 elements, it's like we want the elements as position 0, 1, 2, and 3, okay. So which means we're basically looping on the range 0 to 3 inclusive. So 0 and 3 are part of our range, okay, which means the upper bound for the range is 4, just here, because it's a first 4 elements, okay. But I wanted to explain this to you so that you know the rationale behind this, okay. So if they say the first 5 elements, you just 0, 1, 2, 3, 4, okay. So again, it's very simple. So here we just start our for loop is a for I, it can be anything, in range 4. Now we know range 4 means it's basically generating a range that has, that contains 0, 1, 2, 3, okay, which is just what we want. So finish, and everything is the same. But now here there's a slight difference, okay, because the I here that you get is not the element at all. It's just the position of the element, okay. So you need to fetch the element at position I and print that, okay. If you say print I, then it's just going to print 0, 1, 2, 3 for you, okay. Unlike in like this example here, you see, for X in test string, we just put X because X is actually an element in this string, okay. But here I is just an index. It's just specifying the position of the element that we want, okay. And this is how to access that element. So the list we are looping over is test list, okay, and we want to display the element as position I, so it's just a print test list put element at position I, okay. So if we run this, you see, 9, 7, A, and 4.4. That's what we want, basically, okay. If we were to basically say just I, you see, we get 0, 1, 2, 3, okay, because we are basically only printing the index, okay. Good. And one thing you need to note here, and this is common sense, okay. For example, if you say range 4, which means there should be at least 4 elements in this list, okay. If if we were to change, so let's say how many elements are there in this range. So I don't even know, but let's say we say range 40. Let's say we want to print good, okay, range 40, okay. Now you see that we get an error message, okay. It prints up to the last one, but it tells you that list index out of range, okay. It means that the index here at some point is totally more than the number of elements here, because you go 0, 1, 2, 3, 4, 5, okay. So on the 6th iteration you get an error because there are only you cannot have elements at index 6. Okay, there are only 6 elements here, so you cannot have 7 basically. Okay, that is simple to understand, so just so you know. Okay, now let's see. Okay, so there is another usage option for range. Okay, so you notice that here we only specified the upper bound. So in range n, you specify only the upper limit basically of the range. Okay, and automatically Python assumes that you're starting from 0. Okay, but you could actually change that. You could tell Python to start at a specific number or a specific index and stop at a specific index. Okay, so and the syntax for that is range m comma n. Okay, so you're saying Python start this range at m, or okay, and end at n minus 1. Still note this, that the upper limit is not included. Okay, and that the range only contains integers. That's also something to know. So you start 0, 1, 2, or if you're starting at m, it's m plus 1, m plus 2, up to n minus 1. Okay, so now let's see. Let's say we want range on 2 to 5 inclusive. So in that case, we'll just say range 2, 6. Okay, again, so you see, so this is the range, and we can convert this to a list to see exactly the elements in that range. And the syntax is just lists and on the range, and you can see we have 2, 3, 4, 5 and not 6. Okay, so now let's see, how do we use this in a for loop? Okay, and let's look at a simple example. So now it's using the range function, because definitely there is another way to do this, but I just want to show how you use the range function basically in a for loop. So let's say using the range function, print the last 4 elements, the last 4 elements of the list, this. Okay, and again, simple, this is a list for you. Good. Okay, now we want to determine the last 4 elements of the list. Okay, you know, if we had wanted to print the first 4 elements, it would be simple, right? It's just 0 to 4, right? And in that case, we don't need to specify 0. We just specify the upper limit. But here we need to specify both the lower and upper limit. Okay, because you know, we don't even know where the last 4 elements, or where the last 4 elements starts. Okay, from basically. Okay, so now let's see. So the first thing you do in this scenario is you try to determine the total number of elements in the list. Okay, and this is what we are doing here. Num elements, it's just any name again, and this is the syntax for the number of elements, it's len. Okay, and this gives us the number of elements in that. So now we know that there are, say, 10 or 6 elements or 7, so okay, elements in this list. Okay, but the next task we want to know is, what the next information we would really like to know would be the starting point of the range. Okay, and this is simple. If we know the number of elements in the range, okay, and they want us to start from the last 4 elements, okay, so we just subtract 4 basically from the total number of elements. Okay, so let's take it from here. So this is 0, 1, 2, 3, 4, 5. Okay, so the last 4 elements basically starts from here, right? The last 4 elements. Okay, and so if we want the index of 4, we just subtract 1, 2, 3, 4, 5, 6, 7. There are 7 elements here, so 7 minus 4. Okay, 7 minus 4 is what? 3. Okay, and we know Python lists indices start from 0, so 0, 1, 2, 3. So that's simple. Okay, so this is just like a rule of thumb. Okay, so we know now that the starting point is here. Okay, so we know both the starting point and the end point of the range. And so we can easily loop. So just say for I in range, again, just put the start point, and the end point is just the total number of elements. Finish. Okay, and print again test list. This is our variable, and I is just the the index. Okay, and what we want is the element at that index. Okay, so we run this, and here you go, you get it. Okay, as simple as possible. Okay, then the last use of range is, okay, you can see that in the first two options, okay, let me just show this here. You see here, okay, the elements increment by 1, so 2, 3, 4, every time it just increases by 1. Okay, but there are times when you don't want to go at that fixed interval of 1. Okay, sometimes maybe you want to have a staggered one, maybe 2 intervals of 2, intervals of 3, or so on and so forth. Okay, so Python lets you do that. Okay, so in that case you say m, np, so it means start at m, end at n minus 1 at intervals of p. Okay, so again, let's use this example. 1 to 10, it means 1 to 9 inclusive. That's really what that means, at intervals of 3. Okay, and we could print this basically to see. So you see, so you start at 1, 4, 7. Okay, 1, 4, 7. You don't have 10 because in reality it's actually stopping at 9, and so the next element in this sequence was going to be 10, right? But because you're saying 1 to 10, meaning it's only going to take 9. Okay, so if we were to say 11, okay, not there, basically, now you see you have up to 10, because 11 means it's actually counting up to 10. Good. So let's see how this is used in the for loop. Okay, so let's say we want to print all odd numbers between 10 and 25, basically all the odd numbers. Okay, we know what odd numbers are. They're not divisible by 2. Okay, so again, for every range, okay, what you need to know is your start point for the range, your end point for the range, and the interval, basically. Okay, so for this problem, this is a bit tricky, okay, because 10 is not an odd number, it's even. So you don't want to start from 10, basically. Okay, so you start from 11, which is just the first odd number in the range. So we start from 11. Okay, and again, you don't end at 25 because they're saying inclusive, and 25 is odd, so you end at 26 so that you can count, so that Python can consider 25. So that's something to note. Okay, and the interval here is just 2, basically, because if we start at 11 and we add 1, then we are getting 12, right? So, and 12 is odd, but if we add 2, basically it means we'll get 11, 13, 15, so on and so forth. So you see, so basically you just add this 2 and everything becomes easy. So again, for j in range, start, end, interval, and print j. Here we're printing j itself because we're not taking from any set. Okay, we are just printing the actual numbers here. So, and you see, here you are, 11 to 25. Good, right? So if we were to say here 25, now you see that it stops at 23. Okay, good. Okay, so on. Oh wow, I think this is okay for now so far. Okay, now let's look at nested for loops. Okay, whenever you hear of nested, it just means one thing inside the other, one thing leading to another. Okay, so a nested for loop is just yes, nested, yes. So A nested for loop is just a for loop inside another for loop, okay? And it's actually just the same. Nothing changes. The principles are the same. Everything remains the same. Just follow the principles and it will work, okay? So now let's say we want to print each element, basically like 1, 2, 3, everything. We want to print everything, okay? And this means basically what is going to happen, okay? Let's try to visualize this problem, okay? Now let's say you were doing this by hand, okay? And that's, for me, that's my advice. Whenever you encounter a programming problem, put yourself in the position of the computer. Say, if I were to solve this problem, how would I go about solving it? Okay, so after you've solved it yourself, you've actually come up with a solution strategy. Then you can translate that into a computer language, okay, into a way the computer can do it, okay? So now let's see, what would we do, okay? So if I were to solve this problem, okay, what I would do would be, okay, I would go through this list, like one, okay, every element, take every element, okay, one after the other, okay? So for the outer list, this outer one, this and this, okay, you will see that there are 3 big elements here. So this is one element, okay? An element is just anything separated by a comma, okay? And a list is always enclosed by these square brackets, okay? So this means this is one list, okay? And this is an element in the outer list, which itself is another list, but forget about that for now. So that's what makes it a nested list, okay? Because there's an outer list here, and there is at least one list in this outer list, okay? So let's see. So this is one element, this is one element, this is one element. So the way I would go about this would be, I'll take this first element, write out all the numbers, all the elements in that element. Then I go to the next element, write out again all the elements in that element. Okay, that's tautology. Then up to the last one. So that's basically the strategy, okay? So which means the first task here is really you're running a for loop, because you're saying this and this. So that's for loop. That's a for loop. You're actually going through. Then in each element again, assuming that element is a list, okay, what you're actually doing is you're as well traversing that element, meaning going through each element of that element, okay? So that's the same thing. So now how do we tell the computer to do this? Okay, it's the same. Okay, so we start with the outer loop, okay? Say this guy, okay, this is the outer list, okay? So we loop over that list, okay? So again, we say for x in nested list, which is just our list here. So x here is just an element of this, which itself can be another list. So that's what we're doing it. So for x in nested list, so you have x, okay, but x, bear in mind, is a list, okay? So you're not doing anything, okay, until you get to the list element, okay? So for the second element, I mean here, which is the second list, you also loop over the elements of that list. Here we use a different variable. So let's say y. So for y in x, because now x is an element in this, so you don't say y in nested list, you say y, I mean in x, because x now is our variable, or is our input for this second for loop, okay? So this is your last point. This is your lowest, okay, point. So you just print y. Now if you do this, you see you have 1, 2, 3, 4, 5, 6, 7, 8. That's what Python is doing. So Python starts with this first one, okay. So it prints everything. So what Python does here is that it completes this first before going to the next one. So it takes x, let's say this one which has 1, 2, 3. So it prints 1, prints 2, it prints 3. So this inner loop is finished, okay. Then it goes to the next one. So okay, so now you have completed 1, 2, 3. So it goes to 4, 5. Again, when you get to 4, 5, okay, Python takes, okay, 4, 5. Then it goes to this one, 6, 7, 8. Finish, okay. Okay, now let's say let's see how this works. Okay, so let's say we want to repeat this but without the second for loop, okay, meaning we just want to print x, okay, which is what we have here. For x in nested list, print x. You see what happens? It's not entering into these because you have told x that just print me, Python that just print me x. So when Python starts, x, the first x is 1, 2, 3. The second x is 4, 5. And the third x is 6, 7, 8. So you see, so good. Okay, now let that sink in. So let's look at break statements. Okay, break, as the name implies, a break is just there to let you interrupt the execution of a loop before its completion. Okay, so let's say we want to print all the letters of statement, but maybe we want to stop when we get at E, or we get to E, for example. So in that case, we use a break statement. A break statement will just stop, okay? So let's see, okay? So which means for a break statement to work, there has to be an if a block, because you have to say break if this condition is met, okay? So we go. So this is our list again, okay, and we want to print, okay, so print each element of the simple list, okay, up to and including the element 5, not the elemental position 5, but 5 actually, okay. So which means we want to print C2, 3A, and 5, then stop, okay. And how do we do that? The same for x in test, that everything is fine. You print x again, yes. So but if x is equal to 5, you break. So it's as simple as that. You know, you're just telling it what to do. And now if we were to run this, so you see C2, 3A, and 5, and it stops. It's not going to execute that, okay. And this is very useful when you run large codes, for example, okay. And sometimes you don't know, you really do not have an idea of, how many times you would need to run the loop for. So you can just say, okay, just run. When this condition is satisfied, you stop, okay. So now we go. So let's say let's look at another example. So let's say print each element of the simple list, this one, up to but not including the element 5. And I want you to pay attention here to the position of the print statement relative to the if block, okay. And programming is just logic, simple logic, and understanding, well, in this case, English language, okay. The first one says up to and including the element 5. So which means we want to print the element 5 before breaking the loop, because once you break the loop, all the statements after the loop, after the break, are not going to be executed, because you have told Python to stop, to quit. Okay, so you bear that in mind. Okay, so that's why we had to print this before the break, because we wanted to include element 5. But here they're saying up to, but not including the element 5. So we really do not want to print element 5. So we need to break before printing. So that's the only difference. Okay, so that's why here print after break, here print before break. Okay, so we run this and there's no 5. Good. Okay, and there's another statement called continue statement, like continue. Okay, and again, as the name implies, you're just telling Python in this case, okay, to abandon, okay, the current iteration and move to the next one. Okay, so which means, again, all the statements after the continue statement are not executed for that iteration. And this is something to note. For the break statement, it's not just for that iteration, meaning the for loop actually stops running. Okay, but in the continue statement, it's like putting a hold on that iteration. So if you're on the 6th iteration and it's how do I put this? It encounters the continue statement, then it just stops. Okay, it stops where it is. It does not continue for the 6th iteration, but it moves straight away to the 7th iteration and does everything again. Okay, so let's see what happens. Okay, so now let's say print each element of the simple list, this only if it is an integer. Okay, so we're going through this list, but we're printing only integers. Okay, again, there is another way to do this, but I just want to show how you can do this with continue. Okay, to make you understand what continue means. Okay, so again, the same. So here, let's see. Yes, I know. How did this happen? Okay, now I think this was a typo, because this is like for okay, this is for, how do I call it? This is for while. Okay, so let me see how I'm going to correct this here. Okay, so for good, I knew it, for x in, okay, good. Okay, let's see. Good. Okay, great. Okay, now we see that for, we want this. Okay, we want to print only integers, so we don't want to print C, we don't want to print A, we don't want to print 6.6. okay, and what we do here is, again, the same. This statement just tells Python to loop over this list, but what we want to do here is that, okay, we want to print only if it's an integer. So if it's not an integer, we don't print, we continue. That's just the flip interpretation. Okay, the normal interpretation is print only if it's integer. So you would just say if type x is equal to integer, print. You wouldn't need any continuous statement, but I want us to use continue here. Okay, so in this case, we look at the flip side of the statement. Okay, and the flip side here says if it's not an integer, then don't print, continue to the next element. So this statement is just testing that. So if type x is not integer, continue. So Python will not execute this for this particular case, for x, for this particular value of x. It won't execute this. So it will move basically to the next one. Okay, so if we want to run this, now you see 2, 3, 5, 7, 8. So none of these executed. Good. Okay, so now let's go. Okay, now pass statement. I really pass, as the name implies, pass really means nothing. Okay, you're just telling Python not to do anything, and this is because you cannot have an empty if block, you cannot have an empty for block or an empty while block. Okay, and if you want to have those by every means, which you don't have to, then you need to use a pass. So let's say print each element of the simple list only if it is not a string in this case. Okay, so here we want to print only if it's not a string. Okay, and again, simple. So this is just to loop over this. Now here we test if type X is equal to string, because we want to print only if it is not. Okay, so we can say the easiest way would be if type X is not equal to string, print, but I want us to use pass. Okay, so here we say if type X is equal to string, do nothing. Okay, but you cannot leave this empty, so you have to say something, so you just put pass. So Python will pass that, and else print. Okay, so if we were to run this, see, you'll see. Okay, now let's say we want to delete this and see what happens. You see, expected an indent block, so it's saying you should have something there. Okay, but you don't. Good. Okay, now let's go. So that's really all about for loops. Now let's do while loops. Okay, while loops are like for loops. In fact, you can use while loops in place of for loops if you know what to do. Okay, and the application really is when we don't know, when we don't have an idea how many times we want to do the loop, because you saw that in the case of the for loops, we had to state explicitly that okay, set a range or define a range, or define an iterable. So in that case, you know exactly how many times. Okay, but there are times when you don't know, and in most times, when you write sophisticated programs, you come across these instances a lot. Okay, so and there are two stark differences, or there's a stack, I would say there's a stark difference between for and while loops. Okay, so for a while loop, you need an indexing variable. Okay, you need an indexing variable, and you need to initialize this indexing variable, okay, before you start the loop. So in for loops, Python advances the loop automatically. Okay, so Python checks or reads one input, goes to the next input, goes to the next one automatically. Okay, but for while loops, no. If you do not tell Python to advance, it won't. It will remain in, it will execute that code of block forever. Okay, and that's key. Okay, so now let's put this into context. Okay, so let's say print the numbers from 2 to 15 inclusive. So we want to print from 2 to 15. So as I said earlier, we need to specify an indexing variable. So in this case, our indexing variable is I. Okay, so we're saying I is what we will use to advance the loop, okay, or to make the loop advance. Okay, and we are saying I is 2 because we're starting at 2 basically. Okay, so this is called initialization. You're setting an initial value, or you're attaching an initial value to that variable. Okay, and again, this is how while loops are basically expressed. Okay, so you start, so while, again, small w, or then lowercase, and this is your indexing variable. So you say while, so you're saying basically what you're telling Python is, do execute this code as long as the value of I here is less than or equal to 15. That is what you are telling Python, and we are using less than or equal to because we want to display from 2 to 15 inclusive. If we only wanted to display from 2 to 14, meaning 15 not inclusive, then we would say I less than 15. So it's basic logic, okay? It's just common sense, okay? And everything is the same. So print I, okay? But the next difference here is that you're telling you're telling Python to advance the loop, because if you don't tell Python to advance the loop, it, the value of I will remain constant, will be 2 forever, and which means this loop will run forever because you have told Python to only stop when this is, to stop when this exceeds 15. Okay, so let's run this. Okay, so see, and now let me tell you a bit about this. Okay, how do you increment the variable? We're saying I is equal to I plus 1. Okay, and this is interesting, and I'm sure new to most of you. So what Python does here is that when you say I, you're saying the new value of I is equal to the old value, the previous value of I plus 1, which means you have advanced one step. Okay, so the first time Python executes this code, the initial value is 2, right? So after printing 2 here, then this becomes now 3 because it's 2 plus 1. So the next time it prints 3, the next time it prints 4, and when it gets to 15, it stops after 15. Okay, so now let's see what happens if we didn't have this, if we didn't increment this. Okay, now you see it's still printing. It's still printing 2. You see 2 continuously, and it's still running. Okay, and this is very bad. When you run some big, like you write a big application, and if you're not careful, this can crash your application basically. Okay, so in this case we want to interrupt execution there. Okay, so that's an infinite loop. It's it's an infinite loop. It's running forever. Okay, great. So now you know what to do and what not to do. Okay, so now let's look at this. Okay, so let's look at the second example. Print the characters of a string. I think we did this earlier with a for loop. Now we are doing this with a while loop, just so you see the difference between them. Okay, so again, this is string George. I like that name. Okay, but here we want to print all the characters of George. Okay, and we're starting with with 0 because Python indexing for this string starts from 0. Okay, so that's why we initialize our indexing variable to 0. Okay, so I is equal to 0. Okay, and now let's this is getting interesting. Okay, now we want to run this. Okay, for every for loop, while loop, this is what you need to know. 1, you need to know the initial value of your indexing variable. Okay, I, you need to know that. Okay, and finally you need to know when to stop, your stopping criterion. Okay, your stopping criterion. When do you stop? Okay, because if you don't get those right, then the loop is going to run forever. Okay, so now let's see. Now in this case, we want to print all the elements here. Okay, and so basically all we need to do is we run across, or we traverse the entire length of this variable. Okay, and so if the length of this variable is 10, for example, so which means we want to run from 0 to 9. Keep this in mind, because Python indexing for strings starts at 0. So if there are 10 elements, then your range should be from 0 to 9 inclusive. So that's what we are doing here. So we are now saying the length of this minus 1, basically, because the length will give you the number of elements. Okay, but what we really want is the index of that element, so we subtract 1. Okay, good. And all of this, and there is one new notation here. Basically, it's just the shortened form of I is equal to I plus 1. It's the same. Okay, but Python actually allows this. Okay, so it's a shorthand. I plus equal to 1. It's just as saying, it's not saying I is equal to I plus 1. So if we were to see, you still get George. Okay, good. Now you can also have nested while loops. Just as we have nested for loops, you can have nested while loops. Okay, and we're doing the same example that we did earlier, but with for loops. Okay, we want to print each element of the nested list here. Okay, again, we define a list, but now there are two issues here, okay, that we need to bear in mind. I did say earlier that for every while loop you need to know where you're gonna start. Okay, and secondly, you need to know your stopping criterion. Okay, so in this case, there are two levels of lists, right? You have the outer list and the inner list, so two levels. Okay, so we start. Okay, so you have to initialize. So there is one while loop for each level of listing. Okay, so for this outer level, it's one while loop here. This while loop is for the outer level. Okay, and for the inner level here, it's one while loop. Okay, it's the same as what we did for. So you take this element and you traverse the elements of that element. Okay, so we go. Okay, so we're using index 1 to to represent the indexing variable for the outer loop. Okay, so again, we're starting from 0 because we are doing everything here. So index 1 is equal to 0. Okay, now we start. While index 1 less than or equal to, again, this is simple for you now because we are doing everything, and the length minus 1 gives us the index of the last element. Okay, so while index 1 less than or equal to that. Okay, so let's see what we do. Okay, so which means, I know this is hard, so I'm gonna take my time. Okay, so just try to visualize what is happening. Okay, so this means you are taking each element of this outer loop. So this, and later this, and later this. Okay, so sub list is just getting you the element at this position. Okay, so this gives us the sub list. The sub list is just this element that is at this position. Okay, and then straight away we increment index 1 because we have used that index. And as a rule of thumb, you should try and increment an index as soon as you have finally used it, as long as you don't need it again later on along the while block. Just increment it so you don't forget. Okay, so this is fine. Now we also need to loop over the elements of the sub list, say this one. Okay, again, we need another while loop for that. So we define another indexing variable here index 2, because it's a different one. So any name index 2, again we start with 0 because we want to traverse the entire length of this sublist. Okay, now again the condition is simple. While index 2 is less than or equal to, again we're looping over the sublist, so we use the sublist length. Okay, and now we can print because we are at the lowest point, so we print the element at this point at index 2 of the sublist, and then we increment the sublist index, and it's the same. Okay, just go home, take your time, go through that and see what happens. Okay, and we also have infinite while loops. As the name implies, they run forever until you tell them to stop using a break statement. And this is normally when you have no clue how many times you want to run the loop for. Okay, so now let's use a simple example. So let's say we want to print random numbers between 0 and 15. Okay, but we continue doing this until we generate 0. So for every loop, for every iteration, we generate one number that is between 0 and 15. Okay, we continue doing this unless we generate 0. It's like playing, like maybe die or something. Okay, now let's see. Forget about this guy, okay, because I am importing this module so I can generate a random number. So what you should pay attention to is this structure. Okay, so if you want to do this, all you say is while true, because this condition is always true. Okay, you can either say while true or while true, while false. I think, let me see, we will try while false as well later. Okay, so while true, this is always an infinite loop. Okay, you're saying random. Okay, you're saying generate a random number between 0 and 15. So this is saying generate random between 0 and 15. Okay, and you want to print a random number. Okay, but we want to break when we have 0, so it's the same. So if random number is equal to 0, break, basically. So you see, this is running for us, so it's generating, and when it's 0 it stops. Okay, so you see, because random number, so it's, you run it a different time, you get a different sequence. So you see, so it stops only when we have 0. This is cool, right? Very cool. So you see, so that's the function of a infinite loop. And okay, this is not happening because we are saying false, so the default is actually true, so that's something to note. Okay, but there's another way. Okay, so let's say while j equals 7. Okay, so let's say we say j is equal to 7. Okay, so one way to do that, let's say you don't want to use while true or something, you can basically say and use a variable. Okay, define a variable as that will not change. Okay, that has a constant value. Okay, say j is equal to 7, and you're sure that j is not going to change inside this loop. So you say while j equals 7, do this, okay? And this will continue forever because j is fixed here, it's 7, it's not changing in here, okay? So you see, it's the same. You can put any number if you want, okay, but only make sure that if you have defined j to be 0, then your condition here should be 0 as well, and you'll be fine. Good. So now you can also include an index, okay, if you want to count the number of times you have executed the loop. Okay, so let's say let's assume we want to print randomly generated numbers between 35 and 100 until a number greater than 67.5 is obtained. Okay, print the number of executions. So in this case, we just want to print how many times we had to run the code before obtaining a number that is greater than 67.5. Again, everything is fine. So here we have to include an index to count. So this basically just counts how many times we have traversed this loop. Okay, so you initialize this 0 because we have not started anything yet. Okay, so as soon as you enter the loop, you count. Okay, you increment because it means you have already entered that loop. Okay, so that's why we have a counter is equal to counter plus 1. So you're incrementing your counter. Then you generate a random number between 35 and 100. Here you print the random number here, and here you check if that random number is greater than 67.5. If yes, you basically break. If not, then you continue until, okay? And when you're done with the loop, when you break everything, you print the number of times you executed the while loop, and you can see that this print statement is on the same line as well, so it's not part of the while block. Okay, it's executed after the while block. So let's see. So you see, so in this case, we only run the loop only ran twice, before satisfying our condition. You see, here once, here 3 times, one, good, 5 times, so good. And I'm not going to run this, but this is just to tell you that you can also use continue and pass statements in while loops, okay, as well. So it's not just for for loops. So most of everything you do for for loops, you can do for while loops. So you can have a look at this later.